Saying hey from West Virginia. Good to have you. Hope everybody's doing well. And I think we need to start today with joke of the day because you know it is the best part of the day. Everybody loves joke of the day. So here's today's joke. What do you call a fake noodle? An impasta! Yeah, these are good. These are really good. Okay, so let's get into today's lesson where we're going to translate algebraic expressions. Because what a lot of people tell me is they say, well, I just really struggle with going from words into math symbols. And that's a very common struggle that people have. So I'm going to show you some of the tips and tricks for being able to take words, English words, and turn them into math symbols. So let's first get a couple of terms down, a little bit of terminology. Our first term is a variable. And a variable is called this because it is something that varies. The word variable sounds like varies. And mathematicians are not creative. You're going to get really sick of me saying this, but it's absolutely true. Mathematicians are not creative people. We call it like we see it. So a variable sounds like the word vary, which means that this is representing something that varies. So it's going to represent a number, but we're not quite sure what that number is because that number could change depending on the situation. So because that number could change depending on that situation, then we're going to call that number a symbol. And typically we use a letter. Now you could use a symbol. I mean, you could use like a star. You could use a hashtag. You could use a smiley face. But usually we use a letter to represent that number. And oftentimes the letter is something that goes with the word that it represents to make things a little bit easier. But just know that a variable represents a number, and because it varies, we call it a variable. Now, the second term that we want to talk about before we get into this idea of translating is an algebraic expression. Now, what happens here is there is a difference between an expression and an equation. People oftentimes get the two confused, and a lot of times people will point at something that's really an expression, and they'll say to me, that equation right there. And I'll go, ugh, it's not quite an equation. Now, the difference between these two has, again, to do with what it sounds like. In other words, the word equation sounds like what? Yeah, it sounds like equals. So that means if you have an equation, you have an equal sign in there. Whereas if you don't have an equal sign in there, then your equation really is not an equation. It's just an expression. So in other words, an algebraic expression is a combination of variables, which are those letters or symbols, and numbers. Your expression will use all kinds of mathematical operations like addition, subtraction, multiplication, division. It'll even use powers, which are exponents. We'll talk about that later. And it'll even use roots, which would be like a square root or a cube root or something like that. That's the opposite of a power. But again, we'll get into that later. The whole idea here is the main thing you need to understand at this point is the difference between an expression and an equation. And again, equation sounds like equals. So if it has an equal sign in it, it's an equation. If it does not have an equal sign in it, then it is just an expression. So matter of fact, we probably need to put in here as part of our definition, no equal sign. And that's the big deal about your algebraic expression. There is no equal sign in there. So now that we understand these two terms, let's take a look at this idea of being able to translate from English words into algebraic expressions. I've got a little chart here, and this chart does a great job of summarizing the more common expression or the more common words that we'll see that will give us tips on how to turn those into math symbols. If you see the word plus, obviously you need to turn that into a plus sign. Most people understand that if you see the word sum, that indicates addition. If you see the word more than, now this does not indicate the inequality symbol of more than that looks like this. That's not what this is indicating. We're talking about translating into algebraic expressions. So oftentimes more than will actually indicate plus. If you see the words increased by, increase means to add to it, to make it bigger. So making it bigger would indicate to add. So if you see any of these types types of words that will indicate, put a plus sign in there where you see that word. If you see the word minus, obviously that means to put a minus sign in there. If you see the word difference as opposed to the word some indicating put a plus sign in there because you're adding. Difference indicates you are subtracting. So that would tell you to put a minus sign in there. Less than, again in this case, does not mean your inequality symbol of less than. This time what it's indicating is the idea of going smaller, taking out, subtracting. So that would mean put a minus sign in there. And the word decrease by, again, means I'm starting with something since I'm decreasing by that amount. That means I'm taking away, I'm subtracting it out. So that would indicate put a minus sign wherever you see the word decreased by. So if you see any of these 4 words, that tells you put that minus sign in there where you see that. Now, if you see the word times, obviously that means put a multiplication in symbol in there. This is one that often throws people. The word product indicates multiplication. So when you see the word product, put a multiplication symbol in there. Twice would actually mean 2 times. So you would put 2 times that in there. And obviously if you see the words multiplied by, that means put a multiplication symbol in there. So the more, the one that people struggle with the most is this idea of product. Product means multiplication. Now, the word divide obviously means put a division symbol in there. Quotient is one that throws people off. Quotient means division. And so that's one that we need to pay attention to. Ratio is another one that throws people off. A ratio is a fraction. A fraction is actually a division problem, which a lot of people don't understand. We'll get into that when we talk about fractions. But when you see the word ratio, that as well should indicate to you, put a division symbol where you see that. And obviously the words divide by would mean put a division symbol in there. So again, here's the more common ones that we deal with. The ones that have been starred, those are the ones that people struggle with the most. So let's take a minute and let's practice with this idea of translating from words into algebraic expressions. So I've got 6 examples here, and in each of these examples, we're going to turn our English phrase into that algebraic expression. And what I have here is, again, the ones that are more commonly ones that people struggle with. Most of the ones that deal with addition, people don't have any trouble with that at all. And the fact that addition, you can kind of turn it around. A 2 plus a 3 is the same thing as a 3 plus a 2. So the order doesn't really matter. The same thing with multiplication. Most people don't struggle with multiplication other than the word product. But again, because multiplication is commutative and you can switch the order, a 2 times a 3 is the same thing as a 3 times a 2. So the order doesn't matter. Most people don't struggle with multiplication. It's your subtraction and your quotients that most people have trouble with. So let's take a look at this first one. It says the quotient of 5 in a number. Now remember, we said that this quotient indicates division, but the problem that we're struggling with is what order do we put that in? Do we put the 5 in the front, or do we put this number that we don't know what it is in the front? Now remember, since I don't know what this number is, I'm going to give it a variable. You can use any variable that you want. Most people use an X, but you can use any letter that you want, and for that matter, you could use a symbol if you want to. Some people use an N, which represents number. Some people use an X. It's entirely up to you. So if I call this an X, then I'm trying to decide, does the 5 go in the front or does the X go in the front? Whenever you're dealing with quotient, the first thing you see goes in the front. So being that I see the 5 first, it will go in the front and the X will go in the back. So this is how that I would write it. If you want to use the bar that indicates division, then what you see in front goes on the top. So it would be 5 divided by X. This is the more common way that we would write it, but this is a perfectly fine way to write it, but this is what we usually see. So again, quotient means division. The first number or letter, the first number or variable that you see will go in the front, which would indicate that it goes on the top. So let's take a look at the second one. Sorry. It says twice a number increased by 7. Now twice a number means I'm going to double that number. In other words, I'm going to multiply it by 2. Do I know what that number is? No, I don't. So therefore, I'm going to give it a variable to represent it. This time I'll use an N. Now it says twice that number, which indicates 2 times that number. And to show multiplication, we're just going to let them sit beside each other. What you need to understand and get used to is when things sit up against each other, right up against each other, that indicates multiplication. So these two sitting beside each other indicates they are being multiplied together. So 2 times that number, we're going to increase that by 7. Increased by means I'm adding to it. So I'm going to take this product that I see right here and I'm going to add a 7 to that. There we have taken our algebraic expression, or our words, and translated them into that algebraic expression. Now, notice the next 4 look an awful lot alike, but there are subtle differences between those 4. This one says 8 less a number. This one says a number decreased by 8. This says 8 less, oh, those say the very same thing. Hold on a second, I've got a mistake. This one should say 8 less than a number. My deepest apologies. 8 less than a number. There we go, that's better. As opposed to this one saying 8 less a number. This one says a number subtracted from 8. So they all deal with 8, and believe it or not, they all deal with subtraction. Because we read before that less than is not in this case indicating that inequality symbol, it's indicating subtraction. Decreased by indicates subtraction. Less a number indicates subtraction. That again is not the inequality symbol. And subtracted from indicates subtraction. So now we just have to decide what order to put them in. So let's think about what's happening here. This says 8 less than a number. Now once again, I don't know what that number is, so I'm going to call it an n. But being that this says 8 less than that number, I have to decide what am I starting with. Like if I have a pile of numbers here, and I'm starting with this pile of numbers, and I'm taking out of this. Here's the pile that I'm starting with. I'm taking out of that. Well, in this pile, am I starting with the 8 and taking this many out of the 8? Or am I starting with this many and taking 8 out of it? So the idea is I have to figure out, what am I starting with in this pile? Well, it says 8 less than this. So that indicates to me 8 less than this means I'm starting with this. So I'm starting with the n. So that means I'm starting with this n. I'm taking out of the pile. How much am I taking out? I'm taking 8 out of the pile. So this is the correct way to turn that set of words into an algebraic expression. Now, let's take a look at this one. A number decreased by 8. So again, here's that pile with so many things in it. I know that I'm subtracting out of it, I'm taking out of it. So do I start with this n, this number that I don't know what it is? Do I start with that and take 8 out of it? Or do I start with the 8 and take that number out of there? Which do I start with? A number decreased by. Decreased by 8 means I'm taking 8 out of it. So I'm going to start with this number and I'm going to take 8 out of it. So that's the correct way to write the algebraic expression for those words. Now let's take a look at the next one. Here again, I know I'm subtracting 8 less a number. I don't know what the number is. We'll call it n. But again, since it's subtraction, I got to decide, here's that pile that I'm starting with. Do I take out 8 out of the pile? Or am I starting with 8? 8 less a number. 8 less a number. That means I'm starting with the 8. I'm taking out of it that number. 8 less a number. 8 less a number. So I start with the 8, take the n, that number, out of it. And this is the correct way to translate that one. So let's look at the last one. A number subtracted from 8. Again, subtracted from indicates subtraction. I have this number here that I don't know what it is, but it tells me here's the pile. Am I subtracting the number out of the pile, or am I subtracting 8 out of the pile? What do I start with? It says a number subtracted from 8. Subtracted from. So that tells me that here's the pile. I'm taking that number out of the pile. So I start with the 8 and take away from that. So I will start with this 8 here. I will take out of that the number. This is the correct way to translate that. Okay, so that's how we translate from English words into algebraic expressions, let's take a look now at how to translate using equations, using that equal sign that we had talked about. Okay, so translating words into equations, very, very similar to translating words into algebraic expressions. Just remember the difference between an equation and an expression is the equation sounds like equals, so your equation is going to have an equal sign in it. So the definition of an equation is it's a statement that two algebraic expressions are equal to each other. There you go. You're going to have an equal sign in there because you'll have an expression over here that does not have an equal sign, an expression over here that does not have an equal sign, and you're going to put the equal sign in there to say that the two are the same. So because of that, when you hear words like is the same as or equals, that will tell you that's where the equal sign goes. Other words that mean the same thing are words like, for instance, gives. Gives indicates this gives this. Yields means the very same thing. Is, was, and will be all mean this is this. The two are equal to each other. The two are the same. So if they are the same, then you're going to put that equal sign in there. So let's practice then translating our words into those algebraic symbols again, but this time we're going to use an equal sign because you'll see one of these words in there. So let's take, for instance, our first example. 30 less than 4 times a number gives 54. Aha! There's that word gives, and gives indicates to me there should be an equal sign right there. So I know that I do have an equation. I do know that that equation means equals 54 because it gives 54. I have to see what's on this side of the equation. What is that algebraic expression that's on this side? Believe it or not, 54 in and of itself is an algebraic expression. It's an algebraic expression that only has one number in it. So I need to figure out what's on this side. So let's take a look at what's over here. 30 less than 4 times a number. Okay, remember that less than indicates subtraction. So I know that I'm going to be subtracting somewhere. Here again is that idea of figuring out what am I starting with. So do I start with this pile and take 30 out of it, or do I start with a 30 and take out of that? Well, it says 30 less than something. 30 less than. That indicates that you start with something else and you pull the 30 out of it. You subtract the 30 out of it. So I know what's going to happen is I'm going to subtract 30 and I have to figure out what's in this pile that I'm subtracting 30 from it. So I've taken care of 30 less than. What is it that 30 is less than? 4 times a number. Do you know what that number is? No. There's your variable. There's your unknown. Whenever you figure out what your unknown is, you need to define it by that variable. So here is that n or x or whatever you want it to be. And in fact, I'm going to get a little bit better, and I'm going to say I'm going to define that variable. I haven't done that yet, but let's get a little bit more precise. Let's get a little more mathematical now. And just to make sure everybody knows, I'm going to say let's let n equal that number. So I'm going to say, okay, 4 times that number, and that's what I'm beginning with. 30 less than 4 times the number. Here's 30 less than 4 times that number gives 54. So here's the correct translation. Now, notice that nowhere in these directions does it say solve the equation. It doesn't say anything about solving. It doesn't say anything about what is the number. All the directions say is write the sentence as an equation. We did that. We wrote the sentence as an equation. So we don't have to solve it. I don't have to do anything further. Just simply do the translation, call it done. There's my answer. So let's take a look at a couple more examples. Now you'll notice in these two examples, they look an awful lot alike. I mean, very similar. The product of 12 and a number decreased by 2 is 36. The product of 12 and a number increased by 2 is 36. They are the same thing. What's the only difference between the two? Exactly. There's commas in this one. There's no commas in this one. Now go back to your English class that taught you that what does a comma indicate? What do you do when you see a comma? Exactly, you pause. So what we do here is we put a nice, big, long pause in there. If you put a nice, big, long pause where you see that comma, this will actually be very easy to translate. So watch what happens. The product of 12 and a number increased by 2 is 36. I know that felt weird, but honestly, that nice big long pause makes it so easy to translate this. So let's take a look and do that one more time. The product of 12 and a number. Well, how do you translate that? What does product indicate? Yes, product indicates multiplication. So I'm going to multiply 12 and a number. Do I know what that number is? No. So let's go ahead and define it. Let's let, I'll get creative this time. Let's let x be that number. So I'm going to do 12 times that number. So I have 12 times the x. And now let's deal with the rest of it. So we've done the product of 12 and a number. Now let's continue. Increased by 2. Well, how do you take that and increase it by 2? Yes, increase means add. So I'm going to add 2 to it. And now I'm going to finish it off. And it says is 36. Now remember, is, it means this is that. It equals. So equals 36. And there's the translation. Very easy when you put that big, long pause wherever you see that comma. Now this one has no comma. So it's kind of like a run-on. So this says the product of 12 and a number increased by 2. So because there's no comma in there, that indicates it can't look anything like this. Cannot look like this. So this would tell me the product of 12 and a number that's increased by 2. Well, here's the is 36, so I know I'm going to get an equals 36 in there. Now I have to deal with this part up here. The product of 12 and a number increased by 2. Well, this tells me product means multiplication, so it's 12 times something. What is that 12 being multiplied by? Well, the 12 is being multiplied by the product of 12 and it's being multiplied by this right here, that number that's increased by 2. Well, how do I show a number increased by 2? Yes, that's addition. Do I know what the number is? No. So once again, I'm going to define it and I'm going to say, let's let that x be that number. I'm going to take that number, I'm going to increase it by 2, but now what I'm going to do is I'm going to multiply 12 and that. Now notice it's 12 in all of this, not just 12 times the x, because that's what this indicates. This says just take the 12 and the x and only multiply them together, that's it. That's what this said down here. But remember, these two cannot be the same because there's no commas in here. This can't look like that. But it's 12 times all of this. The way that we show 12 is going to be multiplied to all of that and not just the x, because that's what this indicates, is I'm going to take this and I'm going to put a parentheses around all of this, because that means all of this goes together. The parentheses means that's one big piece all put together. Now I'm going to do 12 times all of that. 12 times the whole thing. Not just the x, yes, 12 times x, but also 12 times the 2 as well. Or in other words, once I've taken this number and added 2 to it, whatever I get out of that, now I'm going to multiply that one by 12, because that's actually what this says. The product of 12 and whatever I get when I take that number and increase it by 2. So I'm going to take that number, increase it by 2, and then I'm going to multiply it by 12. And so this is the correct translation. So again, couple things to remember. One, when you see a comma, put a nice big long pause in there. That will fix it and make it very easy to translate. The second one is anytime you hear the words is the same as, was, will be, yields, gives, and obviously equals, that means put an equal sign in there. So hopefully this helps with translating our words into algebraic expressions and our words into equations. Have a great day.